I brought here this paperclip just to explain what fatigue is,
Fab.
because it's something that most people might not be aware of what it is.
Yeah.
And I think the paperclip, I don't know if the camera will pick it up, but it's the best example I can find. So what we want to know is, if I apply a certain load to a material, which we call stress actually, how many cycles will it endure? So what I'm saying is this: if I sit here on this sofa and I stay here forever, this is statics. But if you go to IKEA, for example, I don't know if you've ever seen the sofas or chairs being tested.
They're always a bit worn, yeah.
But they do. There is a machine.
Oh, they have a machine. I've seen the machines, yeah.
I've seen
and
that.
opening and closing drawers and things.
Yeah, exactly.
Yeah, I've seen this,
What they're showing is fatigue
Yeah,
testing.
yeah.
So doing that wears down, and that's why we call fatigue. It's like getting tired. You go to exercise to the gym, and you get, if you do it once, it's easy. But if you do it 100 times, might not even be reached there. So the materials is exactly the same thing, or well, phenomena is different. But the paperclip, how it works is this. So if I deform the paperclip, I'm just going to deform it a little bit so that I can do it. And I'm going to basically bend it, and I count 1, and I do 2, and 3, and 4, and 5, and 6, and this is taking longer. 8. So I count the number of cycles.
That's a strong one, yeah.
So I count the number of cycles, which is, come on, paperclip.
You've got the world's strongest paperclip.
This usually works very well, but you get the gist of it. I think it's not even deforming well anymore. Oh well, this is the strongest paperclip ever.
It's a trick paperclip.
It's a trick paperclip.
I swapped it out before you came in. I don't know if you noticed.
Come on, there you are.
Okay, that must have been about what, 20?
I don't know,
more?
maybe
That was a lot.
So this is called low cycle fatigue. What I did, which has different, there's different phenomena happening then at high frequency, but the principles are the same. So now if I would apply less deformation, less stress, it would probably take me more cycles until it would snap.
Less stress meaning you're bending less
Yeah.
distance, for example?
For example, yeah.
Okay.
So it would take me longer for it to basically snap. So what we do is, the most basic stuff we do is to have what we call an SN curve, which is a plot. Vertical axis, we have the stress, the load, the force, if you want, but it's typically in terms of stress. And on the horizontal axis, you have the number of cycles. And then you know that stress you applied lasted, I don't know, 10 cycles. So you put there a dot on the 10 cycles. Then you start decreasing, and then you go, and suddenly you have a plot, and you can have an estimate. Okay, now I know if I want the life to be, I don't know, 10,000 cycles, I know that the stress is that one. And with that stress, you can then design the paperclip to.
So what you're talking about is the typical amount of stress a paperclip might be under when someone bends it to put paper inside it, for example.
Well, I'm just using this as an example.
Yeah, of course.
As an example, but could be. But if you want to use, I don't know, you want to actually do the same number of cycles, the same stress, but you want to double the life. So you might want to make the paperclip diameter thicker. But you want to do it optimally. So that's where the engineering comes.
Based on, are you talking about budget and those sort of things as well? And efficiency in production, all that sort of stuff?
All that stuff. Because especially paperclips, if you multiply this by millions or billions, a little bit of increments will have a considerable cost. Yeah. So that's where, I'm sure you can design a paperclip. You don't need to be an engineer for that. But if you want to
I'm not sure I could, to be honest.
But you don't need to be an engineer. You know what I mean? It's just
yeah. But it's a lovely, simple example. I like that.
That's the one I use. It wasn't that successful, but because this paperclip was a trick paperclip, we swapped.
So are you unimpressed? I mean, how long does it usually take for a paperclip to how many cycles?
I don't know. It depends on how much you bend.
What I'm saying is, are you unimpressed by the manufacturing quality of these paperclips? Because the planned obsolescence wasn't consistent.
It wasn't consistent.
So whoever made this, don't buy paperclips from them in the future.
No, they're probably too good. I need to go and call them and say, listen, guys, you're losing money. You don't need all this material. I'll make you save some thousands of pounds or hundreds of thousands of pounds. You can make them thinner. They'll work.